Happy morning, my dear students. Did you learn the yesterday portion? Shall I ask some question from the previous topic? Yes? Okay. What is the general electronic configuration of p block element? What is the general electronic configuration of p block element? Tell me. Okay, correct answer. NS2, NB, 1, 2, 6. Which group have completely filled orbital? P block element, which group is completely filled? Which group? P block, which group is completely filled? Okay, group number 80. Okay. What is the formula for kerinite? What is the formula for kerinite? Na2, B4, O5, OH 4 times 2H2O. Okay, correct answer. What is the atomic number of indium? What is the atomic number of indium? 49. Okay. What is the most common allotropies of oxygen? What is the most common allotropy of oxygen? Okay, dioxygen, ozone. Okay, correct answer. Very good, very good. Okay, today also I am taking the lesson, having many lot of equation. You must take written practice. Now only you take the written practice, otherwise it may be some difficult for you. So today itself you should be learn. Okay, anyhow, today our learning objectives to discuss the preparation and the properties and uses of boron and borons. Discuss the preparation, properties and the uses of boron and borons. Chemical properties of boron. Boron is the only non-metal and less reactive. It shows reactivity at high temperature. Many of its compounds are electron deficient. The 3 points is enough. Boron is the only non-metal and less reactive. It shows reactivity at high temperature. Many of its compounds are electron deficient. Some chemical reaction. Formation of metal borides. Many metals except alkali metals form borides with the general formula MXBY. Next, the reaction. Direct combination of metal with boron. Then we are taking chromium metal. Which metal? Chromium. What is the symbol of chromium? Cr. Chromium reacts with N molecules of boron at the temperature 1500 Kelvin. 1500 Kelvin. We get a metal boride. That is chromium boride. This is the first equation. Can you write this equation? Chromium plus N molecules of boron. The temperature is 1500 Kelvin. We get a metal boride. First equation. The second equation is reduction of metal boron trihalide. Reduction of boron trihalide. Halides means all of you know that fluorine, chlorine, bromine, iron, anyone can be take reduction of boron trihalide. Here, a very good example is boron trichloride. That's a formula is BCl3. Boron trichloride and react with one of the metal, assuming that W as a metal. And the temperature is also 1500 Kelvin. in the presence of hydrogen, we get a metal borate. The formula is WB. W is assumed as a metal and boron, metal borate. And also the evolution of chlorine plus HCl. Now, we need to balance the equation. How can you balance the equation? Here having 3 chlorine, having 2 plus 1, 3. And also boron 1, metal W 1 having. The hydrogen is not balanced. So how can you balance the equation? Simply we can be used here number 2. So now we get the 3 chlorine and also boron 2. So metal also make it 2 here. Now chlorine 6 having, here having only 3. We make 2 here. So again hydrogen 2 here. So we can use 2. Now chlorine is 2 2s are 4, 4 plus 2 6. Equation is balanced. So balance the equation is very very important. It is necessary to balance the equation. The next one is formation of hydride. Formation of hydride. Boron does not react directly with hydrogen. However, it forms a variety of hydride called boranes. It's a very very important. Boron does not react directly with hydrogen. It forms a variety of hydride called boranes. The simplest borane is diborane. The preparation of diborane is a very very important question. It's a repeating board exam question. How is diborane prepared? The question is, how is diborane prepared? Here, boron trifluoride. The formula is boron trifluoride formula BF3. Boron trifluoride on react with sodium hydride. The formula is NaH. Sodium hydride. The temperature is very very important. 450 Kelvin. Boron trifluoride react with the sodium hydride at the temperature is 450 Kelvin. We get diborane. The formula is B2H6. B2H6 and the sodium combines with the fluorine. The sodium combines with fluorine. We get NaF, sodium fluoride. What's the compound? Sodium fluoride. The formula is NaF. So balance the equation is very very important. Balance the. How can you balance the equation? Make it 2 here because boron 2 having. So make it 2 here. Now the fluorine is 2 into 3 is equal to 6. So make it here 6. Now sodium is 6. 6. So the equation is balanced. So here the first one is a direct combination of metals with boron. Second one is reduction of metal boron trihalide. Third one is the formation of hydride. The question is very 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 important. Very very important question. A repeating question. So next one is the formation of boron trihalide. Here boron reacts with the halogen. Boron reacts with the halogen. We can be take fluorine, chlorine, bromine, iodine. So simply we can be take X2, that is halogen. Boron reacts with the halogen to form boron trihalide. So halogen 2 here, halogen 3 here. So balance the equation is very very important. How can you balance the equation? Make it 2 here. So here 3. Here I have 2. Now the equation is balanced. Next subheading is formation of boron nitride. Formation of boron nitride. This is also important question, very very important question. Here boron reacts with nitrogen to form boron nitride. How can you balance the equation? Nitrogen 2 having, we make it 2 here. So boron 2 having, make it 2 here. Now the equation is balanced. The temperature is also given. The two questions, the formation of boron trihalide and the formation of boron nitride. Next one, the formation of oxide. Formation of oxide. So boron reacts with oxygen. Boron reacts with oxygen to form boron trioxide B2O3. Boron reacts are heated at 900 degrees Celsius. We get boron trioxide. How can you balance the equation? Here having 2 oxygen, here having 3 oxygen. So how can you balance the equation? Here make it a 2 here. So 2 2s are 4 boron and oxygen 3. Is the equation balanced? Okay, balanced. So what is the formula for boron nitride? Bn. What is the formula for boron trioxide? B2O3. B2O3. Next, reaction with alkali and acid. Very, very, very important question. Reaction with acid and alkali. First we are taking reaction. Boron react with acid. Here we are oxidizing acid such as sulfuric acid and also nitric acid we are taking. Oxidizing acid such as sulfuric acid and nitric acid. Boron reacts with acid, that is a sulfuric acid, H2SO4, the king of acid. Sulfuric acid. We get boric acid formula H3BO4. H3BO3, boric acid. The formula for boric acid is H3BO3. Okay, and sulfate having, so sulfur dioxide gas is also evolved. That's the equation. Boron reacts with the sulfuric acid, we get boric acid and also sulfur dioxide gas. How can you balance the equation? Here 2 hydrogen, here having 3 hydrogen. So make it 2 here. So 2 into 3 is equal to 6. We can make it here. So how much boron is there? 2 boron. So make it 2 boron. Then sulfur, how much is there? 3. Make it 3. Now the equation is balanced. Next one, boron reacts with nitric acid. Boron reacts with nitric acid. What is the formula for nitric acid? HNO3. HNO3. Boron reacts with nitric acid, we get boric acid. The formula is H3BO3. Here nitrate having, so we get NO2 gas. NO2 gas. So how can you balance the equation? 3 hydrogen, here having only 1 hydrogen, so make it 3 here. Next one, nitrogen how much having? 3, so make it 3 here. Then everything is balanced. It's a very, very important question, especially for the formation of boron nitride, very, very important question. And also boron react with acids, also very, very important. And also the boric acid formula H3BO3. The next one, the last one is boron reacts with the sodium hydroxide. Boron with sodium hydroxide. Boron reacts with sodium hydroxide. What's the formula for sodium hydroxide? NaOH. Boron reacts with the sodium hydroxide. We get sodium borate. What is the formula for sodium borate? Na3BO3. That's the evolution of hydrogen gas. So how much sodium is there? 3 sodium. So make it here having only 1 sodium. Here boron 1. Oxygen 1. Here having 3. So how can you balance the equation? Make it 2 here. So 2 into 3 is equal to 6. Oxygen also now balanced. Now boron here having 2, so make it 2 here. Hydrogen 6, 3 here. Now the equation is balanced. Next about the uses of boron. What are the uses? What are the uses of boron? What are the uses? Very, very important uses. It is boron isotope, that is boron 10, that is boron isotope is used as a moderator in nuclear reactor. One of the use is used in the nuclear reactor. The second use is it is used as a rocket fuel. Rocket fuel, it is used for a rocket fuel igniter. The third one is it is essential for cell wall of plant. Okay. Cell wall. Rocket fuel. So at least 3 uses you must learn. At least 3 uses for the 3-mark question. The next subheading is borax. The formula for borax is Na2B4O7 with water molecules. How is borax prepared? That is a question. How is borax prepared? Before that, what is borax? Borax is a sodium salt of tetraboric acid. What is borax? Borax is a sodium salt of tetraboric acid. It is obtained, it is prepared from columnate ore. Which ore? Columnate ore by boiling its solution with the sodium carbonate. It is how it is prepared? It is prepared from columnate ore by the boiling its solution with sodium carbonate. Here, first we learn what is the formula for columnate ore. That is Ca2B6O11. Ca2B6O11. It is the formula for columnate ore with the sodium carbonate. What is the formula for sodium carbonate? Na2CO3. And the presence of water molecules H2O. We get what is the formula? Na2B4O7 plus calcium carbonate CaCO3 and also plus calcium hydroxide CaOH twice calcium hydroxide. So columnate ore, what's the formula? Ca2B6O11. Sodium carbonate formula Na2CO3 plus water molecules. We get borax Na2B4O7 plus calcium carbonate CaCO3 and calcium hydroxide. Here given symbol heat. How can you balance the equation? Here 2 calcium, having 2 calcium, boron 6, here having boron 4, 11, 7. So it is a equation balance is necessary. How can you solve this equation? We can be used number 2 here. So here having 4 calcium, so make it 3 here. So 4 calcium. Next about here boron, I think that 6 2s are 12. So make it here 3. That is 4 3s are 12. 4 3s are 12. Next about the sodium. Here having 3 sodium, here having 2, those make 2, 3 here. And water H2O. Okay. Now the equation is balanced. Okay. First of all, you should be in number 2. So we get 4 molecules, that is 4 atom, 2 molecules of calcium. Here 2 2s are 4. Here having 3, here having 4. So the calcium is balanced. Next about the boron. 2 into 6 is equal to 12. So make it 3 here. 3 into 4 is equal to 12. Next about the sodium. 3 2s are 6. Here also make it 3 here. Now the equation is balanced. Next about the physical properties of borax. Physical properties. Actually, physical properties. Physical properties. Borax is a basic in nature. It's a very, very important point. Basic in nature. Physical properties, basic in nature, and its solution in hot water in alkali is alkali, and it is dissociates into acid and sodium hydroxide. First of all, borax plus water. We are taking borax. What is the formula for borax? Na2B4O7. Borax on react with water. Water we get boric acid. What is the formula for boric acid? H3BO3 plus sodium combines with here hydroxyl, water plus this H plus OH. This sodium combines with OH, we get a sodium hydroxide. So borax plus water, we get the boric acid and sodium hydroxide. Then how can we solve this equation? How can we balance the equation? First we make it here. Here boron is 4, here having only 1. So make it 4 here. So boron is balanced. Next about the sodium, Na2. Here also make it a 2. And hydrogen, 4 into 3 is equal to 12. 12 plus 2, that is 14. So make it 7 here. 7 2s are 14. The first equation is balanced. Okay. First here boron 4. So make it 4 here. Now hydrogen 4 3s are 12. 12 plus 2. So the equation is balanced. Next about on heating borax, on heating to form a transparent borax beads. Borax on heating, that is what is the formula for borax? Na2B4O7. Okay. And we are taking the 10 molecules of water. 10 molecules of water on heating. What is happening here? The 10 molecules of water is leaving out. Minus H2O. It's 10 molecules leaving out. What's the remaining product? Na2B4O7. 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 Again undergoes on heating, we get a sodium metaborate. We get a, again on heating, we get a sodium metaborate formula NaBO2. And the evolution of B2O3, boron trioxide. Sodium metaborate. Okay. Then how can you balance the equation? Here having 2 sodium, here having only 1 sodium. So make it 2 here. And already boron also balanced, everything balanced. Oxygen also 6, 4 plus 3, 7. Here also 7. Equation is balanced. Next one. Borax reacts with acid. We are taking acid. Borax reacts with acid. Here we are taking 2 acid, 2 types of acid, that is HCl and sulfuric acid. We are taking HCl and sulfuric acid. Hydrochloric acid and sulfuric acid. Here borax, what is the formula for borax? Na2B4O7. This borax on reacts with hydrochloric acid and with water. Borax on reacts with hydrochloric acid and water, we get a boric acid. What is the formula for boric acid? H3BO3, and the sodium combines with the chlorine. The sodium combines with the chlorine, we get NaCl. So first of all, how can you balance the equation? Here having only boron 4, here having only 1. So make it 4 here. Now hydrogen 4 into 3 is equal to 12. Make it here 7, sorry not 7, make it a 5 here. 5 2s are 10, 10 plus 2, okay, 12. Okay, that is the balance. Next about sodium, 2, make it 2 here. Chlorine is balanced. Then borax react with the hydrochloric acid in the presence of water, we get boric acid and sodium chloride. For boric acid, H3BO3. Next one, borax react with the sulfuric acid. Borax reacts with the sulfuric acid, formula H2SO4, the presence of water. We get same product, that is boric acid. What is the formula for boric acid? H3BO3 plus sodium sulfate, Na2SO4, sodium sulfate. How can we balance the equation? Here having 4 boron, they are having only 1, so make it 4 here. So that is over. Next about same that water 5, sodium, 2 sodium. Now is it balanced? Sulfuric acid, 1 molecules, water. Okay, now the equation is balanced. Next about the very important question, very important. What happens? Borax reacts with ammonium chloride. What happens? Borax reacts with ammonium chloride. Ammonium chloride formula NH4Cl. Borax reacts with ammonium chloride. Borax Na2B4O7. Borax reacts the ammonium chloride formula NH4Cl. Ammonium chloride. We get the first product, we get sodium chloride. That is sodium combines with this chlorine. Now the sodium combines with the chlorine, we get sodium chloride, NaCl plus boron combines with the nitrogen. Borons combines with the nitrogen, we get Bn. What is Bn? Boron nitride. And boron react with the oxygen. This boron react with the oxygen, we get boron trioxide B2O3. B2O3 plus hydrogen with the oxygen, we get water. Hydrogen plus oxygen, we get water, H2O. Okay. Borax plus ammonium chloride. First of all, this sodium combines with the chlorine, we get sodium chloride. Boron combines with the nitrogen, we get boron nitride. Boron combines with the oxygen, we get boron trioxide. This hydrogen combines the oxygen, we get water. How can we balance the equation? First of all, sodium, 2 sodium here, so make it 2 here. Now 2 chlorine is there, so make it 2 here. So chlorine is balanced. How much nitrogen having? 2 nitrogen, so make it 2 here. And hydrogen how much having? 2 into 4 is equal to 8, so make it 4 here. So equation is balanced. Okay. Next topic is uses of borax. What are the uses? A 2-mark question. What are the uses? First one, borax is used for the identification of colored metal ions. Used as a colored identification of colored metal ions. So first application, first uses. Next one, it is also used as a manufacture of optical and borosilicate glass. Optical and boro glass, enamels, etc. Next one, it is used in the flux in metallurgy. Flux in metallurgy. These are the uses. 2-mark question. It's an important question. It is used the identification of colored metal ions, and it is used in the manufacture of optical and borosilicate glasses. It is also used as a flux in metallurgy, and also act as a preservative. It's a very important preservative. Okay. Next one is next our topic is boric acid. Boric acid preparation. Boric acid. What is the formula for boric acid? Already we learned. What is the formula for boric acid? H3BO3. Boric acid. Otherwise can be right, or otherwise one more formula, BOH thrice. BOH thrice. Boric acid. How is boric acid prepared? It's an important question. Very, very important question. Boric acid can be extracted from borax. And also one more columnate. Boric acid is prepared from borax. What is the formula for borax? Na2B4O7. Borax. Borax and react with the sulfuric acid. Sulfuric acid formula H2SO4 and plus water H2O. Already the equation we learned. Boric acid how is prepared? First one we are taking borax. Borax formula Na2B4O7 and react with the sulfuric acid and water, we get boric acid H3BO3 plus here having sulfate, so we get sodium combines with the sulfate, we get sodium sulfate Na2SO4. Okay. Na2SO4. How can you balance the equation? Here having 4 boron, here having only 1 boron. So make it 4 here. And sodium 2 here. Hydrogen 4 3s are 12. So make it 5 here. So 5 2s are 10 and plus. Okay. Equation is balanced. Next one. Again, boric acid is prepared from columnate ore. Already I told you about the formula Ca2B6O11. Columnate ore. This one react with water and also sulfur dioxide. We are giving sulfur dioxide. We get a calcium bisulfide. What's the product? Calcium bisulfide with boric acid H3BO3 plus calcium bisulfide formula CaHSO twice. Calcium bisulfide. Then how can you balance the equation? Here 2 calcium is there. So make it 2 calcium is over. Then about boric acid, here having 6 boron. So make it here 6. Now the hydrogen, 6 3s are 80. Make it 11 here. And sulfur 4. So make it 2 2s are 4. So make it 4 here. Now the equation is balanced. Okay. Calcium having 2. So make it 2 here. And sulfide having 2 2s are 4. So make it 4 here. Then the remaining hydrogen, totally hydrogen 12 plus 4. So 11 plus 11 into 2 is equal to 22. Okay. Now the equation is balanced. Next about the properties of boric acid. What are the properties? Properties of boric acid. This is also an important question. Boric acid is a colorless, transparent crystal. Colorless, transparent. It's a colorless, transparent crystal. It's a very weak monobasic acid. Very weak monobasic acid. 2 points is enough. And next about this boric acid on reacts with water. Boric acid, we can be write BOH thrice. This boric acid on reacts with water H2O. This equilibrium reaction, both forward and backward reaction, we get hydronium ion, H3O plus. Hydronium ion, one of the H plus ions is attached to this water, we get a hydronium ion, that is a H plus ions, extra having, and remaining we get a BOH 4 times ions. This is one of the ions. Here hydroxyl group is donating a proton. It accepts the hydroxyl ion and donating a proton, one of the proton to water. So here H2O is converted into a H3O plus ion, that is a hydronium ion. Okay, hydronium ion with borate ions. Okay, next one, it reacts with the sodium hydroxide. One of the next one reaction properties, it reacts with the sodium hydroxide. Boric acid formula H3BO3 and reacts with the 1 molecules of sodium hydroxide NaOH. We get NaBO2. What is the formula for NaBO2? Sodium metaborate. NaBO2. We get a NaBO2, sodium metaborate plus water. How can you solve this equation? How can you balance the equation? Here hydrogen having only 1 hydrogen, here having 2 hydrogen, 2 2s are make it 2 here. So here 3 plus 1 equation balanced. Next one, boric acid H3BO3 on reacts with the 2 molecules of sodium hydroxide. We are taking 2 molecules of sodium hydroxide, 2 NaOH. 2 molecules of sodium hydroxide we get sodium tetraborate. What's the formula? Na2B4O7 plus water. Plus water. First of all, boric acid react with the sodium hydroxide we get a sodium metaborate. And boric acid on react with the 2 molecules of sodium hydroxide we get sodium tetraborate. Then how can we balance the equation? Here having 4 boron, here having only 1 boron, so make it 4 here. Then the hydrogen, 4 3s are 12, 12 plus 2, 14. So here we can make it a 7, 7 2s are 14. Now the equation is balanced. Next we can mark the book back question. So page number 55, question number 1. Page number 55, please all of you turn over the page number 55, question number 1. Write a short note on anomalous properties of the first element of P block element. The answer, page number 29. Answer is in page number 29. The page number 29, the last paragraph. They are having subgetting anomalous properties of the first element. In P block element, the first member of each group differs from the other element of the corresponding group, and also the 3 factors. What are the 3 factors? Small size of the first member. Second one, high ionization enthalpy and high electron negativity. The third point, absence of d orbital in their valency shell. That much. Then question number 2. Describe briefly allotropism in P block element with specific reference to carbon. Page number 30. Page number 30, last paragraph, allotropism in P block element. The first line, some element exists in more than one crystalline or molecular form in the same physical state. For example, carbon exists as a diamond and graphite. And also page number 31, first the tabular column, second point, carbon. Boron after that carbon. The carbon only is enough. Carbon, diamond,
Carbon, the most common allotrope is diamond, graphite, graphene, fullerenes, carbon nanotubes. Question number 3, book back question. Question number 3, boron does not react directly with hydrogen. Suggest one method to prepare diboron from BF3, boron trifluoride. Page number 32. Page number 32. The formation of hydride, the last paragraph. Before that, the formation of hydride, the first line is enough. Boron does not react directly with hydrogen. However, it forms a variety of hydride called boranes. The symbol boron is diboron, B2H6. The other larger boron can be prepared from diboron. Treatment of gaseous boron trifluoride with sodium hydride around 450 Kelvin gives diboron. With that equation, 2BF3 plus 6NaH gives 450 Kelvin. The presence of 450 Kelvin, we get diboron B2H6 plus NaF, 6 molecules of NaF. Then the last question is, give the uses of borax. Page number 34. Uses of borax, page number 34. Today already I told you about that. It is used for the identification of colored metal ions and manufacture of optical and borosilicate glass enamels and glasses for pottery. It is also used as a flux in metallurgy and act as a preservative. A very, very important question. 4 question is over. Then our today assignment. What is the today assignment? Write the preparation and the properties of borax and boric acid. Write the preparation and the properties of borax and boric acid. The page number 33 and 34. Page number 33 and 34.